Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 13, Part 2. We'll be working on model building and diagnostics, as well as residual analysis. Okay, remember in our regression model, for the simple regression model, we have yi equals beta 0 plus beta 1 xi plus epsilon I. Remember that those random errors, those epsilon i's, are independent. They follow a normal distribution with mean 0 and variance sigma squared. We can calculate all of the residuals by taking the observed yi minus the predicted yi. For our residual analysis, we know that the subjects are independent. There's not a plot necessarily that we can do to check for this independence, but you should think about the sampling scheme to make sure that it is true that your subjects are independent. However, we can plot the order of your subjects, the i's, with the epsilon i's. So we can look at a plot of the subject, right, versus the residuals. And overall, there should be a random pattern because we shouldn't notice anything about subjects and residuals as they go. All right. The next thing is we need normality of the histograms. So the way that we can do that is we can plot a histogram of the residuals, right? So suppose we fit a model in R and we calculated fit one being our linear model of Y following X, right? Then summary of fit one, $ residuals, should give us the residuals. We can just take a histogram of these residuals and be able to see, do these look like bell-shaped in a normal distribution? So in our first plot, those look pretty normal. And when we look at our normal probability plot, all those points lie on a line. So that looks pretty good. Whereas in our second data set, if we notice our residuals look a bit skewed, and the normal probability plot, the data points don't fall on a line. So we'd have issues in our second data set. Our second set of residuals, we probably need to fix up our model a bit because it's not following the assumptions very well. Okay. We need a constant variance of our residuals. So one thing we can do is we can plot our fitted values for our I hats, and we're going to plot that against the residuals. And once again, we have a line at 0 and we should see no pattern for the fitted values. You don't want your residuals to start growing as your fitted values grow. This would, that would give you an issue about non-constant variance, right? Across the fitted values. So this is bad. All right, another thing that we want to look at is all of our xi's. So we want to look at each of our individual predictors and the residuals. And you don't want to see a pattern when you look at this, because if you saw a pattern, let's suppose that our xi's versus our residuals look something like this, that might tell you that you need to transform your x variables. All right. So if you're asking yourself in general, how does your model fit the data? You're really asking yourself, do we need to transform any of the variables, or have we omitted any important variables? So essentially, you're once again checking those fitted values, and you're checking each of your predictors versus the residuals, and you're checking to see that there's no pattern. If there's a pattern, you need to take extra steps to fit a better model. All right, I hope you learned something today. I'll see you next time.